Welcome to my final year project 2 presentation. My name is Anak Ginti Amphan, Matric number 63989. My supervisor is Madam Inson Binti and my examiner is Dr. Mohamad Nazim bin Jambli. The title of my project is Smart Power Strip Socket. So first, the introduction. In this video, all the technology, software and hardware that are used to implement the Smart Power Strip Socket will be discussed. This video also cover in depth regarding the development environment used in the function implementation, the user interface, as well as brief discussion on developing the system. This video allow the viewer to understand how the system was developed and the tools required in producing the system. Okay, next, the development environment. Smart Power Strip Socket software site was developed with the help of Arduino IDE, which means Integrated Development Environment, to code the Arduino, and MIT Apps Inventor 2 to create an application to control the Arduino, in which the Arduino control the power strip socket connected to it. The Arduino Integrated Development IDE is a cross-platform program written in C and C++ function. It is used to write and upload computer code to Arduino compatible port, as well as other manufacturer development board with the support of third-party core. MIT Apps Inventor, on the other hand, is a web application integrated development environment that was initially created by Google and is now maintained by the Massachusetts Institute of Technology, MIT. It enables a non-programmer to build applications for two operating systems, Android and iOS, for free. For the hardware side, it was assembled with the help of Circuit.io website, which provide the schematic to assemble the Arduino and its module. The relay module connected to the Arduino is then connected to the power strip socket. Next, we talk about the mobile apps development. The mobile apps for the system was developed using MIT Apps Inventor 2 that control the device remotely using a Bluetooth connection. The advantage of using MIT Apps Inventor 2 was that it was free to use. The website for beginner or non-programmer to build an application for both iOS and Android. Since the project only focused on Android, the application can only be used by user that has an Android phone. It's easy to use because to create an application, the user just need to drag and drop the component into a design view and use the Visual Block language to program the application, the application behavior. This subsequently reduced the cost and time for developing this project because of the need to buy software and time to learn to use a new software to develop the application for the system. Next, the MIT Apps Inventor 2 is divided into two. One is the designer view, where the user can design the layout view of the application. The second view is the block view. Here, the user can program the behavior of the application. For example, in the design view, the user put button for some action, but without the programming, the behavior of the button in the designer view will just be an empty button without any function. Examples of screenshot is shown in the figure. Okay, next, the Arduino code development. Arduino integrated development or environment, or Arduino IDE, is a popular tool for users that wanted to implement code on the Arduino board. The reason is that the user can easily include a library that people usually use in Sketchtab, and it will automatically include a library that have been downloaded into your code. User can also manually search for library to be included in it by using the library manager on the Tools tab. There, the user can search for the library library the user wanted to use for the Arduino board. If the library that the user wanted cannot be found on the library manager, the user can Google the library that the user wanted and download it directly. Then the user need to pass into the library folder before included into the implemented code. Next, device development. The power strip socket was assembled using 3 socket plugs attached next to each other. Then the neutral and earth wire is connected to each of the respective socket plug, except for the live wire. The live wire will be going to the relay module where it will be split into 3. All 3 of the live wire will be then go to COM, which means common, on each separate relay. After that, 3 live wire will be connected to the NO, which normally is known as normally open, and go to each power plug. This will enable the Arduino board to control the flow of the live current to each socket. Without the live current, the socket will not be turned on. This is controlled by the relay, which will allow the live current to flow to the socket, and the socket will then turn on. Except for the power strip socket, all the Arduino board and module are assembled using the design from circuit.io, but there are a few modifications made accordingly. Next is the user interface. This part will discuss the user interface that had been developed for Smart Power Strip Socket (SPSS). A screenshot of the application user interface was shown to deliver a better viewing experience, and a discussion was made for every user interface to clarify why the user interface was developed in such a way. The security login implemented for the system. The figure is the user interface for the security login of the application. In this interface, the user need to input his or her username and password and click on the login button for verification. If the username and password are correct, the user will be sent to this correct choose socket screen. But if it was incorrect, a message will appear in red telling the user that he or she have entered the wrong username or password. From there, the user can try again by inputting the correct username and password. Okay, next is choose which socket to control. The figure is the user interface for choose the socket screen. In this interface, the user can press on each of the image or socket button to enter the respective socket to control the on or off function remotely. By holding the socket button, the user can edit the name of each of the socket to their preferences, and by leaving it empty, it will put in a default name such as socket 1. If the user press the logout button, the user will be directed back to the login page. Okay, next is the turn on or off electrical appliances remotely. The figure is the interface for the socket 1 screen. User can press the on or off button to remotely turn on or off the device immediately. When the user press the on or off button, but the user is not connected to the device via Bluetooth, a notification will appear saying the Bluetooth is not available and not connected to Bluetooth device. There are two messages that will appear. This is because of two things. Number one is because the device is not turned on, or number two, the user is out of reach of the Bluetooth device. If the user press the timer button, the application will take the user to the timer screen, and same with the schedule button, where the application will take the user to the schedule screen. The next is the timer function to turn on or off a power socket. The figure is the user interface for the set timer screen. This interface allows the user to set a timer for the device to turn on or off based on the user preferences. First, the user need to set the time by pressing on the set timer button. Then the user need to choose to turn on or off the device when the time reach the specification of the user by pressing the on or off button. So by default, the application will input the current time, the current real time, and uh, an on option when the user enter the page. After that, the user just need to press the send button to send the instruction to the device, to the Arduino. So when the timer reach the designated time, the device will turn on or off based on the user preferences. The screen will also display the message of when the device will turn on or off at the time set by the user. Next, the schedule function to turn on or off a power socket. The figure is the user interface for the set schedule time and day screen. Here, the user can set the time and day the device will turn on or off based on the user preferences. Almost the same as a set timer interface, but the user can choose to repeat the day the device turning on or off. For example, the user choose to repeat the device turning on Monday at specific time. When the device detects that the day is Monday and the time set by the user is the same, the device will turn on repeatedly on Monday at that specific time. Next is the discussion. While developing the system, some significant problem could be found. The list below explain all the problems that were faced. Number one is the time consumption to learn the C programming language was quite long, but once I understand how to use its syntax, the C programming language was found to be flexible and user-friendly. Second is time consuming to learn how to code all the module of the Arduino. For example, the relay module, the RTC module, the Bluetooth module was quite long. But with the example provided on the internet, I could understand how to use all the code needed to operate the module. Number three, the initial plan was to build a 4 power strip socket, but the lack of space on the wooden board to implement the device was too small to fit a 4 power strip socket. So only 3 power socket were implemented to become a 3 power strip, 3 plug power strip. But the application still being developed to accommodate 4 power strip socket based uh, on the design in chapter 3. Okay, the listed problem is meant to clarify why the system was implemented in such a way. In summary, some problem had arose while developing the smart power strip socket.
Okay, okay. Today I will demonstrate on how to operate this smart power strip socket prototype. But first, let's plug in this smart power strip socket. This plug, I will plug it in. Okay, with everything turned on, let's first we need to install the apps, SPSS apps. Let's focus. Okay, we need to install the SPSS apps. Now let's now we need to pair with the Bluetooth. Pair Bluetooth. Let's search. May take a while. Okay, here you see HC 05. Let's press on this, then the password is 1234. Press OK. Okay, you can see it's pairing SC05. Okay, now let's go back. So here we need to, let's focus. Okay, username, we need to input the username and password. So the username is user. I use simple username and password. User 1234. Login. So here, so I already let's focus on this. I already changed the name, but if you want it to be default, oops, let's go back. Default, you can just leave it blank and click OK. Let's focus. Okay, it will be socket 1. You just need to press and hold it to change the name of the socket. So here I put in lamp. Let's put in lamp. Okay, I put in lamp here. So click in there will be lamp here, also be lamp. Okay, let's change it back to the original name, the default name. Just leave it blank and click OK. So the name will be back to socket 1. Okay, let's socket 1 is this one is socket 1, 2 and 3. I cannot implement the fourth one because the board is only this long. It's not enough for me to install a fourth one, so it just be 3 power strip socket. So let's turn off this light, the socket 1, 2 and 3. Let's turn it off. So let's press on off. Okay, you can see. So let's press on. Okay. Okay, seems to be a problem. Good. Okay, on, off, on, off, on, off, on, off. Okay, on. Okay, on, off, off, on, off, on, off. Okay, let's try the timer. The timer is, we will set the timer for the time to set off, for on or off. Okay, let's focus. Okay, press this to set the timer. This is the current time, 2:04 AM. let's set it off 2 minutes. So the 2 hours and 05 minutes it will turn off or on. Let's set it to on, because this is off. Let's put it on. Then here you can see the message before you send it. On timer will set off at 2:06 a.m. Can also set it off by pressing this. Off timer will set off at 2:06 a.m. But I want it to turn on so we can see the result. Turn on, and we press send. Now we need to wait for the result to turn on. Okay. Meanwhile, let's turn off the Bluetooth. Let's turn it off. Okay. So you can see the result when see the result. If the Bluetooth is not connected, it will display Bluetooth is not available, not connected to a Bluetooth device. So you need to connect to a Bluetooth for it to send the instruction to the Arduino. So let's focus. Okay, 205. Okay, 206. It will automatically turn on. So let's set it off again. I'll put it to 07. 207. Okay, click OK. We set off at 207. So I will not touch to prove it. Will turn off at 207. Okay. Seems to be a problem. Let's check. So it's now it's let's focus, 2:07 a.m. So now I want to set the light off at 2:08 a.m. Click OK. Then we will send. We will off timer. Reset off at 8:05. Okay, send. Okay, now we wait until. Oops, it's already 2:08. So will not turn on. Let's set it at. Now it's 2:08. Okay, set it at 2:09, and we need to press send. So let's wait. Set off at 2:08. Focus. Okay, you see it automatically turn off. So now what we need to do is, now we move on to the schedule function. So schedule function, it's similar to timer, but there are days included and repeat function. Focus. Yeah. Okay, repeat function. So first is set the timer. Let's put it to 11 a.m. Click OK, and I want it to turn on. So press on, and today is Monday. So I'll put Monday. So on timer will set off at 2:11 a.m. on Monday. Okay, press send. Okay, now we wait to 11 a.m. Then it will turn on. Okay, you can see it will turn on. Okay, let's focus. Okay, the repeat function is to repeat, for example, the next Monday, if I press this, the next Monday it will turn on at 2:11 a.m. again. If I press this, it will turn only today, and after today it will delete the function, and it will not turn on again at the next week Monday. If I press this, tick this box, repeat box, it will turn on again on the next Monday at 2:11 a.m. So this is the function of repeat. It will save the time and the day, but it will turn on again the next Monday. So this is for socket 1. For socket 2, it is the same. So let's demonstrate on socket 2. So I have a vacuum here that I will use to turn on, and then have to is to demonstrate that it have enough power to to power a vacuum, a high voltage equipment. So currently it's on. Okay, if I press this, it will turn on. So I will turn it off first. Okay, off. Okay, I press it. Okay, let's try turning it. Okay, on. Okay, let's put it, we'll call it like this then. So on. Okay, you can see the light is still on. It will not affect because it is separate relay connection. So now the same for timer and everything. Timer and the schedule. Okay. So okay, that's all for the demonstration. So the lookup function is if I, for example, I close the app. So for example, I close the app. If I press on again, I will not. I don't need to log in again. But if I press on the logout and I exit the app, when I enter the apps again, I need to log in again. Okay, you can see I need to log in again. So I don't need to log in again if I already log in. So that's all for the demonstration. Thank you.